Hello, so here we let X denote the time spent studying by students in the week before final exams. So the random variable X here follows a normal distribution where sigma is equal to 8 and the number of students N is equal to 4. So the standard error of the sampling distribution of the sample mean, that's sigma sub X bar, which is going to be equal to sigma divided by the square root of N. So that's 8 divided by the square root of 4, or 8 over 4, or 8 over 2, which is going to be equal to 4. So we then have for part A here that the sample mean exceeds the population mean by more than 2 hours. So we have the probability that X bar is greater than mu plus 2, which is going to be equal to the probability that of X bar minus mu, which is greater than 2. So this gives us that the probability that X bar minus mu over sigma is greater than 2 over 4. So we have the probability then that Z is going to be greater than 0.5, giving us the probability this is equal to 1 minus the probability that Z is less than or equal to 0.5, which is going to be equal to 1 minus 0.6915, which is going to be equal to 0.3085. So therefore, the probability that the sample mean exceeds the population mean by more than 2 hours is going to be 0.3085. Then for part B, we want the sample mean more than 3 hours below the population mean. So we want the probability that mu minus X bar is going to be greater than 3. So this is going to be equal to the probability that Z is going to be less than or equal to negative 0.75, which gives us 0.2266. So we have the probability that the sample mean is more than 3 hours below the population mean is going to be 0.2266. And then we have for part C that the sample mean differs from the population mean by more than 4 hours. So now we have the probability that the absolute value of X bar minus mu is going to be greater than 4. So this is going to be equal to the probability that X bar minus mu over sigma is going to be greater than 4 over 4, or 1, plus the probability that X bar minus mu is going to be less than negative 4. This is going to give us 1 minus the probability that Z is less than 1 plus the probability that Z is less than negative 1, which is going to give us here 1 minus 0.8413 plus 0.1587, which we get here. This is equal to 0.3174. So we have the probability that the sample mean differs from the population mean by more than 4 hours is going to be 0.3174. And then for part D, we consider another independent sample of 10 students. And we know that as a sample size increases, the standard error is going to decrease. Therefore, without doing any calculations, we directly state the probability in part A is decreasing when we calculate the probability by using the size 10. And the probability in part B is increasing when we calculate the probability of using the size 10. And the probability of C is also decreasing is also decreasing when we calculate the probability using a size 10.